Welcome to another episode of XR Frontier. My name is Jürgen Morse, and today we're going to demystify the whole concept of digital twins. You cannot walk out, talk about digitization, and do not hear the word digital twin. Everybody is building, everybody is talking about digital twins. Now, in a lot of cases, they are actually not talking about a digital twin. And today I will focus a little bit on now what exactly is a digital twin to make sure that you understand what a digital twin is when you meet it in a certain discussion somewhere. And then you know that there are also differences between a digital model. I can already tell you in the middle there's a digital shadow, and then we have the actual digital twin. Now let's first look at the definition of a digital twin. A digital twin is basically a virtual representation of a physical object, of a process, or of a system. So it can be a virtual representation of many different things. Most of the time it is in manufacturing, but you can see it also in the meantime in cities where you have a potential digital twin of a city. And you are able to not only see the data, you can simulate with the data, and then you can also access, or you can actually act upon the data. That is basically a digital twin. So it is a representation that's virtual of a real in life asset, process, or let's say city or manufacturing process. Now, important to understand is you have real-time data integration, meaning what's going on right now, that is something that you can actually see, and that's something that you can actually do with. You have the ability to simulate, so you can play with what-if scenarios. I see this data, I build a simulation. If you look at a digital twin of a city, you get in the data, the real-time data, you see, okay, I have a traffic jam, and then you can do certain simulations from what will now happen if I start shifting or start changing the sequence of the green and red lights, for instance. You only become a digital twin if you only allow the model, or in this case the shadow, also to act upon it. Then you actually are operating in a digital twin mode. So data-driven decisions, that is something that you actually have to look at. So the model, real-time data integration, the ability to simulate, and then actually to act upon these models. Now, what is there so different? What we already have for a long time are digital models. They are used to, for instance, build the structure of a building and to check if statically the building is strong enough, or if it can withstand, for instance, a certain earthquake. Same thing with the manufacturing process. Here you can also bring your whole manufacturing and start modeling your manufacturing process. Now let's start our journey towards the digital twin. What I said is we need to have real-time data. Now, no matter what it's a city, no matter what it's a building, no matter what it's a process, no matter what it's one asset, you collect real-time on-stream data and you show them in the digital model that you already have in a certain representation. It can be a simple 2D sheet as a representation on a computer screen, it can be actually a 3D environment where you show it, but you show the results of the real-time data. That's where you actually move from a digital model into a digital shadow. Now, in the shadow, you also have the capabilities of actually starting to simulate and playing with those what-if scenarios. What if I speed up, for instance, the speed of my manufacturing line? What if I bring other components in? Like I said before, the example, when I start juggling around with the time sequence of the red and green lights. There are so many things that you can actually do inside a digital model, so you can simulate. But as long as you do not close the loop towards the actual process, you are staying in the digital shadow. And if you look at many discussions, and if you look at many topics that we have, and if you look at many representations what people bring, whether it's online or whatever, most of the time they're actually talking about a digital shadow. It's only when we say, okay, now we're going to actually act, so the digital shadow based on the simulation and based on what we see is actually going to do something with the data, and it's going to steer the manufacturing process, it's going to steer, for instance, the traffic stream, but changing the sequence of the green and red lights, for instance. It is moving up the speed of the manufacturing process and actually bringing other components into the manufacturing process. Then we are actually talking about a digital twin. Again, let me repeat. When you have just a virtual representation of a physical object, whether it's a part or a pump, or a process or a city, then we talk about a model. I've modeled my city. When we show actual data, it can be anything, I talked about traffic already a couple of times, but it can also be the flows of water or the temperatures in the city. It can be so many different things. If you show real-time data and you model with those data and you actually simulate some things with your data, you move from a digital model into a digital shadow. And that is, like I said already before, where a lot stops. The moment where you enable a second stream where the model, the shadow now, based on the real-time data, based on the simulation, is allowed to act, then you are actually talking about a digital twin. So keep that in mind, the difference between a model, which is a pure representation, a shadow, which is a representation including real-time data and the ability to simulate. And last thing, the digital twin, where you actually act also on the data and on the simulations that you make. Now, the second thing where you see a lot of discussions is, should it be 2D or 3D? When I hear people talk about 3D objects or about extended reality, immediately this term digital twin comes to fore. This is not necessarily the case. Sometimes I can just have a chair and I have a 3D model of that chair, then it's actually, like I said, a 3D model. Now, the same thing for 2D. If you have a 2D design of your chair, then it's 2D model. When you do the same thing for a car, you can have your car on a 2D computer screen, and you can start integrating real-time data. For instance, somebody can track how fast I drive, what the environment is, what the temperatures are going on the tarmac, for instance, when I drive a car. Well, then that person has a digital shadow of my car in that case. He can see real-time data. And now when he starts simulating that there is a certain curve coming in, he starts playing with the degrees in the curve, then he can see from, okay, with this speed, will Jürgen spin out of this curve, yes or no? Then he is in a 2D shadow. When somebody now is actually seeing, based on the simulation, okay, we are coming up to a 60-degree curve, and with the present speed, Jürgen will spin out of the curve, and he will feed this data into my car, and my car starts decreasing its speed, then you talk about he has now a 2D digital twin of my car. Now you can do exactly the same thing in 3D. When we talk about extended reality, we make it spatial. So now we put on virtual reality goggles. So the person that is sitting in this car is feeling like he's sitting in my driver's position, and you are in this model. As soon as he also sees on his screen the speed that I drive, what I see around me at that point in time, then this person actually has a digital shadow or is sitting in a 3D digital shadow in extended reality in this case. Now when he can also simulate and see from, okay, he's going to get out, he's not going to get this curve, 60 degrees with this speed, it's not going to work, then, and he can actually act, and in that case, the car starts to decrease its speed again while I'm driving, then he has a digital 3D twin of my car, and this is how it works. So now this is explained a little bit about what's a digital model, shadow, and a digital twin, and that it can be in 2D or in 3D. They are both possibilities. So 3D is not immediately a digital twin. No. Be aware of that as well. And now, when you look about a digital twin, you can build a digital twin in different levels. And what do I mean with it? Especially when you look at large manufacturing companies, when you look at manufacturing lines, for instance, there you can have, let's say, a machine. And in this case, let's choose the machine. The machine is a pump. The pump has certain parts. One of those parts can have an actual digital twin, where, for instance, you monitor the stress on this part, and you can see how this part then behaves in the shadow mode, to give you an example. If you actually also start reacting on, okay, in this case, we see that our component might get overstressed, and this is fed into the process, and you start changing your process conditions, then you act on a component part. The same thing you can do on the asset part, meaning you're going to track the whole pump. You can have the model of the pump when you feed it, and you also can see real-time data and simulate them. Then you have the shadow of an asset, or the pump in this case. And when you actually feed it back so that the pump is being optimized based on the data and the simulations, then you have a digital twin of the asset. You can go one step further, and you can make a digital twin of a system. And here I look, for instance, at a whole manufacturing production line. The whole line is constructed as a model. It is filled with data, real-time data with potential simulations as a shadow. And as soon as you allow this shadow to actually steer aspects in real time, in real life, in your actual process, then you talk about a digital twin of your system. And you can go one step further, and that means you have a process digital twin. Typically, a chemical factory is here a very nice example, or a steel factory where you have a model of the whole steel factory with all its components and its assets and its different systems. You see the real-time data in the shadow, what's going on, and then you actually allow the model and the simulations in the shadow to act and compensate wherever necessary. In that case, you have, again, the digital twin of your process. So, as a recap, what should you remember from today? 1, there's a difference between a digital model, which is static or representation, a digital shadow where you see actual real-time data and you have the ability to do simulations, and the next layer is a digital twin, but the digital twin will act upon the actual process as we know it in the real world. You can have digital twins, digital shadows, and digital models in 2D or in 3D. 3D is not necessarily equal to digital twin. And the third thing that you'll learn today is you can have it for a component, you can have it for an asset, you can have it for a system, and you can have it for a process. And when you look, for instance, at a city, there you are looking at the level of a process. Thank you very much for looking at this episode about demystifying the digital twin. And thank you for watching XR Frontier. See you next time. Bye-bye.